Imagine a lone spacecraft approaching a chunk of rock drifting through the depths of space. Inside that asteroid lies more than just dust. It could hold water, precious metals, and building materials for future lunar bases or refueling stations bound for Mars. This isn't science fiction anymore. Multiple companies and agencies are already planning how to mine asteroids, hoping to spark a cosmic gold rush that might transform our future in space. Yet with any grand venture come massive technological hurdles, uncertain economies, and profound ethical questions. Let's explore this emerging frontier and see how space rocks might become the stepping stones for humanity's expansion across the solar system. Historically, asteroids have captured our attention mainly as potential threats that could collide with Earth. More recently, however, we've become interested in the wealth they may contain. These celestial objects can be rich in metals like iron, nickel, cobalt, platinum, and even gold. Some hold water and other volatile substances crucial for sustaining life or manufacturing rocket fuel. Think about the global economy on Earth. It runs on an immense flow of minerals and metals, often extracted at significant environmental cost. If space mining works out, it might offer a new supply chain that helps preserve Earth's ecosystems while fueling breakthroughs in manufacturing and exploration. Why asteroids instead of other celestial bodies? Mining the Moon or Mars is possible, but both have significant gravity wells that make landing, extraction, and launch more difficult. Many asteroids, by contrast, especially near-Earth asteroids, orbit relatively close to our planet. They have little gravity, which simplifies landing, drilling, and takeoff. Some even pass Earth every few years, creating windows that fit nicely into mission timelines. This lower barrier to entry makes asteroids prime candidates for the first serious forays into off-world resource extraction. The concept of mining asteroids has been around in science fiction for decades, but it remained mostly theoretical until the early 2010s. That's when private companies like Planetary Resources and Deep Space Industries announced plans to locate and eventually mine these distant treasure troves. Despite funding challenges and shifting market realities, their bold visions marked a turning point, showing that the idea wasn't just for government agencies. Suddenly, commercial ambitions joined scientific curiosity, all underpinned by the lure of cosmic riches. And the economic incentives could be enormous. Even a relatively small, metal-rich asteroid might contain billions or trillions of dollars worth of platinum or other valuable metals. However, the biggest initial payoff might not be shipping metals back to Earth. Many experts see asteroid resources as more valuable in space itself. For manufacturing habitats, creating rocket fuel, or providing life support for off-world colonies. Water can be split into hydrogen and oxygen for propellant. Metals and minerals can be 3D printed into spacecraft parts, or the beams of orbital stations. By using materials already in space, we could save on the staggering costs of launching everything from Earth. Still, extracting these riches is anything but easy. Asteroids are tiny and often rotate, making it tricky for a spacecraft to latch onto them in microgravity. Mining equipment must function in an environment where dust floats freely, threatening to clog or damage machinery. Engineers have proposed various methods, from specialized drills to lasers that vaporize minerals, capturing the released material. Another idea is heating the asteroid to release water vapor, which can be collected in a control chamber. After extraction, the task of transporting resources looms large. Rockets need efficient propulsion and precise navigation to move material from the asteroid back to Earth's orbit, or another destination, without burning more fuel than the cargo is worth. Several space agencies are already doing preliminary work. NASA's OSIRIS-REx mission gathered samples from the asteroid Bennu, and the Japanese Aerospace Exploration Agency, or JAXA, achieved similar feats with its Hayabusa missions. Though these sample returns are small, they prove we can rendezvous with asteroids, land on them, and come back. Such achievements lay a foundation for larger-scale endeavors, showing investors and policymakers that asteroid mining is not pure fantasy. But while technology slowly advances, the legal and ethical landscape remains murky. The Outer Space Treaty of 1967 states that no nation can claim ownership of celestial bodies. Does that mean it's fair game to mine an asteroid and sell its resources? Current interpretations suggest that while you can't own an asteroid itself, You can own whatever materials you extract, similar to fishing in international waters. The United States and Luxembourg have passed laws supporting private resource claims in space, yet international consensus is still evolving. Many wonder if we risk a new era of colonial-style resource grabs, complete with the potential for conflict or monopoly. Questions of morality also arise. Some worry that once we start harvesting off-world resources, we might replicate environmentally harmful practices that have scarred Earth. Others argue that asteroids, being lifeless, pose no threat to ecosystems. But what if humanity's ambitions eventually extend to moons or planets that might harbor microbial life? We'd then be facing the same ethical dilemmas we have here on Earth. How do we balance exploration and profit with preserving natural habitats, even alien ones? Economic inequities could also deepen. Not all nations have the technology or capital to pursue asteroid mining. If a few powerful entities corner the market on space resources, wealth gaps could widen. Proponents counter that a larger resource pool might uplift more people globally, especially if space-based materials reduce the environmental damage we do on Earth. Nevertheless, these are big ifs, and how the profits of asteroid mining would be distributed remains an open question. Meanwhile, the cost of launching missions is dropping, thanks to reusable rockets and innovations in spacecraft design. Private firms are racing to develop heavy-lift vehicles capable of carrying mining equipment, and even robotic swarms designed to work autonomously. If they succeed, we could see an orbital network of refineries, 3D printing facilities, and fuel depots. That infrastructure might power not only mining missions, but also deeper journeys to the Moon, Mars, and beyond. Another often cited benefit is the potential to stabilize or enlarge supplies of critical materials. Earthly industries rely on rare minerals, sometimes found in only a few regions, leading to geopolitical tension and price volatility. If asteroid mining made those materials more plentiful, we could see a shift in global markets. Yet there's a catch. Flooding the market with space-mined metals might crash their value, complicating the lucrative forecasts that drew investors in the first place. Beyond commercial gain, many people are drawn to asteroid mining for its role in making humanity an interplanetary species. If we can access resources in space, fuel, water, building materials, we can construct outposts and stations that don't depend entirely on Earth. Orbital assembly lines could someday build larger ships for voyages to distant destinations. Over time, we might see a web of space-based industry supporting everything from tourism to scientific research. That grand vision suggests a future in which the solar system itself becomes our industrial and exploratory playground. However, not everyone is on board with funneling massive funds into off-world mining. Critics note that Earth faces urgent challenges, from climate change to poverty, that demand immediate action and investment. Proponents respond that space technologies often generate spin-offs, new materials, energy solutions, robotics that can address problems on Earth too. They also argue that humanity has a natural drive to explore and expand. Asteroid mining could be part of a strategy to ensure our long-time survival. Whether these justifications resonate depends largely on how society values space exploration versus immediate earthly needs. Of course, space is unforgiving. Missions can fail due to hardware malfunctions, navigation errors, or solar storms. The financial risks are enormous, and insurance frameworks for space mining ventures are still untested. A catastrophic failure might dampen enthusiasm and investment for years. Yet, as with other high-risk frontiers like deep-sea drilling or Arctic exploration, breakthroughs often come through trial, error, and persistence. Collaboration might be the key to mitigating some of these risks. Partnerships among governments, private firms, and research institutions can spread costs and share expertise. International agreements could be standards for safety, resource claims, and dispute resolution, preventing a chaotic land grab in space. The International Space Station is a successful model of nations working together. Perhaps asteroid mining could follow a similar path. Realistically, the timeline for large-scale asteroid mining is uncertain. Some optimists believe it could unfold in the next few decades as launch costs drop and robotics advance. Others suspect we won't see true commercial operations until later in the century, given the technical and legal complexities. In the meantime, incremental steps like sending prospecting missions to survey promising asteroids will shape our understanding of what's feasible. Small robotic drills could collect samples and test extraction methods, beaming data back to Earth. Successful trials might pave the way for bigger efforts, including in-orbit refineries and manufacturing hubs. There's also an element of wonder. A few generations ago, asteroids were little more than spots of light in our telescopes. Now we can imagine them powering future expeditions and even serving as building blocks for space habitats. If done responsibly, this shift could mark a new era of exploration, one where space isn't merely a place we visit, but a realm we develop, with all the opportunities and responsibilities that entails. Ultimately, asteroid mining sits at the intersection of commerce, science, and ethics. Will we treat space as a shared resource to benefit everyone, or allow a scramble for wealth that echoes our more contentious histories? Could it be a path to sustainability on Earth and beyond, or a distraction from urgent problems here at home? One thing is certain, the potential is vast, and each new advance, each prospecting mission, each legal framework, each technological leap brings us closer to a future in which the line between Earth's industries and the final frontier blurs. Thank you for exploring this vision of interplanetary mining. We are at the threshold of a revolution in how we gather resources and expand our reach across the solar system. The stakes are high, the challenges are daunting, and the ethical questions real. Yet the dream of turning asteroids into gateways for human progress continues to inspire. If we handle it wisely, we may well look back on this era as the moment we learn to tap the riches of space, and in doing so, learn to be better stewards of our home planet and the cosmos beyond.